Okay, 2.5. Okay, so solving problems involving rate of change. Solving problems with rate of change. Okay, so the instantaneous rate of change is 0 at both the maximum and minimum values. So let me close the lights. Okay, so key thing to know that rate of change is 0 at both maximum and minimum points. That's because when you're drawing a tangent, it is a flat line, flat horizontal line. Okay, so it is has a rate of change is 0. When graphed, the tangent will be a horizontal line. We'll just set that there. Okay, so to prove a maximum exists, the slope of the tangent to the left will be positive, and the slope to the right will be negative. To prove that a minimum exists, it's the opposite. Okay, so it would be negative on the left side and then positive on the right side. So for instance, if I had a graph that looked like such, which would be a cubic function. We have a maximum and minimum value at both points. We have a maximum here, and we have a minimum value here. One second. Okay, so it is 0 because a tangent line would be horizontal here, and it would be horizontal here. Okay, but to prove that it is a maximum minimum, if we didn't know it was a maximum, to prove, what we have to do is find the tangent, the slope of the tangent to the left of this point. So we're looking at the tangent left to this point, and then the tangent right to this point. Okay, when reading left to right, the tangent to the left of the maximum will always be positive, and the tangent to the right of the maximum will always be negative. So this would be a positive slope, and this will be a negative slope. So positive slope, negative slope. Likewise, when we're looking at a minimum, we'll have a negative slope before the point and a positive slope after the point. So this would be negative, and this would be positive. That's if we wanted to prove that it was a maximum minimum. Maybe we didn't know. So what you would have to do is then find the slope to the left and slope to the right and see if it's positive or negative. And the other thing you could do is if you find the slope on both sides, average it out, and it comes up to 0, that also proves that it is a maximum or a minimum value. Okay, so to determine if it is a max or min, you could do the slopes on both sides and average out to 0. If you just want to know if it is a max or it is a min, then you can do the slopes, and if it's positive negative or negative positive, then you can tell which one it is. So let's go through an example of this. Okay, so the point -2 and 4. Just give me a second. The point -2 and 4 is the maximum or minimum value of the function here. Use the difference quotient to verify that the slope of the tangent at the given point is 0. Okay, so we should know, it's saying it's a max or a minimum, so it's one of those. So looking at the equation, it is a positive value, so it should be a minimum at this point. But we're just going to prove that it is, proving that the slope is 0. So we know if it's a slope of 0, then it is a maximum or a minimum at that point. Okay, so it wants us to use the difference quotient for this one. So we're looking at this point here, so this is our x value. So difference quotient is, so we have a minus f at a minus h over h, and then fa plus h minus f at a all over h. Okay, so this is to the left, this is to the right, and then we have to do the average, which hopefully, if we did it right, it'll give us 0. Okay, so f at a, so we're looking at -2. So f at -2, we already know what the answer is. It tells us it is 4. So f at, I'm just going to write the extra step here. So f at -2, subtract f at, so be careful here. -2 minus a 0.01. Remember, h is 0.01. So it's -2 minus a 0.01 is actually -0.01. Okay, all over 0.01. And over here, -2 plus 0.01 is -1.99. Subtract f at 2, all over 0.01. Okay, so we know f at -2 is 4. It tells us that. So we have a 4. Subtract. Now I have to do, I'm going to plug in -2.01 into the equation. So -2.01 squared equals, oops, plus 4 times -2.01 equals plus 8. I get an answer of 4.0001. And when you answer this out, you get an answer of -0.01. Okay, likewise here, if you plug in -1.99, you get 4.0001. Subtract 4. Divide by 0.01. If you do that, you get positive 0.01. Okay, so we know it's a minimum now because it's negative to the left of the point of the max or minimum, and it's positive after that point. So we know it's a minimum value. Now we just have to prove that it is if we average these out and it equals 0. So now this is the step 1, step 2, and now step 3. We average them out, so -0.01 plus 0.01 divided by 2, and that gives you the answer of 0. Okay, so since the rate of change at -2 is 0, that proves it is a maximum or minimum value. Okay, so since the rate of change at -2, because what we did was found the rate of change at -2, since it is 0, then we know that is a max or minimum value. Okay, moving on to the last example. Okay, use an algebraic strategy to verify that the point 4.5 and -60.75 for the function is either a maximum or minimum. So we have to prove that it's maximum or minimum. So I'm just going to change the process here. So use a strategy. So what I'm going to do is I'm going to use preceding and following. Proceeding and following. Let me see if I can get an angle. Okay, so I'm going to do preceding and following. We just want to prove it is a max or minimum. It's telling you we have to say if it's either it's a max or a min. So we just need to know the slopes. We don't need to know that it's 0 at that point. It just wants to know which one it is. So it's telling us that it is one of them. We just have to know which one. So we have to do the slopes here. So if I do the slope to the left, slopes to the right, then I'll be able to tell. So I'm going to do proceeding and following. So I'm going to do proceeding first. So it'll be f at 4.5. Subtract f at I'll pick a point before, so I'll just use an easy one, which is 4, all over 4.5 minus 4. Likewise, for my following, since I went 0.5 lower than 4.5, then I have to do 0.5 higher. So I would have to do f at 5. F at 5 minus f at 4.5, all over 5 minus 4.5. You guys could have used the difference quotient method if you would like to. This is just easier to plug into my calculator, to be honest. So f at 4.5, it gives us the answer already, so negative 60.75. I believe I already wrote this out. Minus a negative 60, so that becomes plus, divided by 0.5, so I get negative 0.75 divided by 0.5 gives me negative 1.5. So to the left, it's a negative 1.5. Now, if we get a positive here, then we know it is going to be minimum. So f at 5, I have it written down, is negative 60 minus negative 60.75 all over 0.5. So again, we get now positive 0.75 over 0.5, which is 1.5 positive. Okay, so what that means, so this is a quadratic function. So at this point, and it's a positive, it's so you could tell by the equation that it is going to be a minimum because this was a positive a value, but we just want to prove it. So at negative 4, so something way down here. Okay, so something very low, minus 60. So what we did was we found the slope right before it. So the slope here was negative. So we had a negative slope to the left. Okay, and then the slope right after it was positive. Okay, so if it's negative then positive, that proves that it was a minimum value. Okay, and if you want to take one step further to prove that it was a minimum, you would just average these out. If you add these two together, divide by 2, you get 0. So that also proves that it was a minimum point. Okay. That is all the questions for 2.5. Oh, sorry, homework here. 111, 1 to 4, 5A, 6AD, and 10. And then they have the review questions here. So we'll be doing this. This is for Monday. Okay, just a reminder, the tests for cohort A, it's going to be October 6th. And for cohort B, it's going to be October 9th. Okay, I know we don't have any next week. We had to push it just based on how this occurs. Let's see. Oh yeah, so this is for Monday and this will be for Tuesday. Okay, everyone take care.